Okay, capacitor and dielectric. So 2.3, capacitor with dielectric. So what is a dielectric? Dielectric is defined as a non-conducting or insulating material placed between the plates of the capacitor. So when a dielectric such as rubber, glass or wax paper is inserted between the plates of the capacitance increased by the factor of epsilon r, which is called as the dielectric constant, means that relative permittivity of the material. Okay, as you can see that we have a metal plate here, and then we insert the dielectric. The blue one is inside between the metal plates. Okay, so we have two types of the capacitor. First is Airfield Capacitor, means that the gap between this metal plate is filled by the air. Okay, so for the next one is capacitor with dielectric, means that you insert between these two metal plate with the something like insulating material, such we call it as dielectric. Okay, so for Airfield Capacitor, so means that the equation that we use to calculate capacitance of the capacitor C is C0. You denote as C0 because dia adalah we consider as capacitance, not lah basic capacitor, C0. Okay, so C0 is equal to epsilon naught A over D. Okay, so epsilon naught is a permittivity of a free space. Okay, so A is a surface area of each plate and D is a distance between two plates. Okay, for capacitor with dielectric, they have special insulated that we insert between two metal plate. Kita masukkan dalam metal plate tadi. Okay, kepingan, ikutlah kepingan rubber, glass or wax paper. So equation of capacitor with dielectric we denote as C without note. Okay, kalau C0 tu adalah by Airfield, tapi kalau capacitor with dielectric kita denote dia sebagai C saja. So C is equal to epsilon naught A over D and times with ER. ER is which call it as dielectric constant ataupun relative permittivity of material. Or we can rewrite by equation C is equal to epsilon not epsilon R A over D. Okay, or you can simplify as, because epsilon is equal to epsilon naught times epsilon R, so we can rewrite equation as C equal to epsilon A over D, where epsilon is equal to permittivity of dielectric material. Okay, so they're based on material lah. Okay, so before we learn about dielectric, actually kita ada belajar. Okay, kalau soalan tanya you capacitor changing is depend on what, maksudnya capacitor akan berubah sebab apa? Contoh, so dekat sini kita boleh cakap dia guna basic formula C yang relate hanya kepada epsilon not A over D. Okay, so maksudnya dekat sini you boleh cakap kapasitor ni akan berubah pada dua faktor. Pertama, changing in area. Yang kedua adalah changing in distance between two plates. Okay, so C akan berubah kalau A berubah atau D berubah. Okay, kalau analogi kepada C, changing of C depends on apa? Pada A, pada D, dan satu lagi adalah inserting dielectric pada dielectric. So ada tiga cara untuk kita tukar kapasitor kita. Pertama, kita tukar dia punya area. Kedua, kita tukar dia punya D. Dan ketiga adalah bila kita insert dielectric. Okay, so you akan tanya saya, oh madam, kenapa C equal to Q over V ni tak boleh? Okay, yang ini dia macam saya cakap, C ni kalau you tanya C, kapasitor hanya depends pada apa? Pada tiga benda yang saya sebut tadi. Okay, ini just pelengkap dia sahaja. Okay, so kalau dia tanya daripada awak, kapasitor bergantung kepada apa? Dia bergantung kepada basic formula dia, iaitu yang ini. Okay, ni basic formula dia, iaitu epsilon naught A over D. Jadi C akan berubah kalau A berubah, D berubah, dan insert dielectric. Kalau yang ini macam mana? Okay, selalunya ini kita guna comparison bila? Okay, bila kita insert dielectric, contoh bila kita insert dielectric mungkin ada perubahan terhadap V ataupun terhadap Q. So dia akan relate lah, C ni berubah jadi apa, macam tu. Okay, faham? Tapi kalau dia kata analogi basic dia changing, kita akan guna this one untuk compare equation. Okay, Alright, so next adalah the advantage of inserting the dielectric between the plates of the capacitor. So increase the capacitance. Bila kita insert dielectric, C akan increase. Okay, dan dia akan increase maximum operating voltage. So V akan tinggi, and then possible mechanical support between the plates, which allow the plates to be close together without touching. As you know that sebenarnya C equal to epsilon naught A over D, contohlah So D ni, C ni akan increase kalau D ni serapat mungkin. Antara plate ni dia akan paling close, tapi dia tak boleh bersentuh. Kalau dia bersentuh, dia akan jadi proses lain lah. Okay, tak boleh bersentuh. Jadi macam mana kita nak dapatkan jarak ni paling dekat? Bila kita insert dielectric. Bila kita insert dielectric kat dalam ni, so jarak antara dua distant plate ni akan jadi semakin dekat lah. Dia cerobohi oleh benda lain lah, macam tu kan. So plates to be close together without touching. So dia boleh increasekan capacitance.